Hi, welcome back. The previous lecture we talked about probabilities, and we did so because we're going to use probabilities in this lecture to talk about decision making under uncertainty. And to do that, we're going to introduce a new technique, a model known as decision tree models. Now, those decision tree models are really going to be useful in terms of making decisions when there's lots of contingencies, when there's probabilistic events, when we don't know the future state of the world. So a big reason we want to learn this model is just to be better thinkers, to make better choices, make better decisions, rather than just sort of throw up our hands and say, I can't figure out what to do, I think I'm going to choose this. Now there's going to be two other reasons as well. One is going to be we're going to use them to infer things about the world, about other people's choices. So we're going to see someone's choice, and from that we can get some understanding of how that person thinks about the world, so we can, again, use it to explain what's going on. And then the third reason for fun is we'll use these decision trees to actually maybe learn a little bit about ourselves. A fun example at the end. So let's get started. What is a decision tree? Decision tree is pretty straightforward. What you do is you think, I've got some choice I can make. Maybe I can, buy something or not. And, if I don't buy it, maybe my benefit is 0. And if I buy it, maybe my benefit is +5. Well, if that's the case, then I should buy it, right? Because it's got a positive value. So decision trees gives this really simple thing where we draw branches representing our choices, and then we choose the branch that has the highest payoff. Well, we want to do this, though, when the choices are a little bit harder, when there's all sorts of contingencies and probabilities. So here's an example. Imagine the following scenario. You're planning a trip to a city, and you've got a ticket to go to a museum, let's say, from 1 to 2. And suppose the museum's quite a ways from the train station. So you look at train ticket prices, and you see you can buy a ticket for the 3 o'clock train for only $200. But the 4 o'clock train is $400. So you're trying to think, boy, should I buy that, should I try and save money by buying that ticket for the 3 o'clock train before it sells out? Now, there's a 40% chance you're not going to make the train. So you're not going to think, oh my gosh, should I buy the ticket or not, given there's a 40% chance I'm not going to make it. And if I don't make it, then I'm going to have to buy 2 tickets. I'm going to basically throw away the $200. Well, how do we make that sort of choice? Well, it's not very hard. What we can do is we can draw a decision tree. Now, the way to draw these trees is we're going to put a square box to represent a decision node. And I've got a choice. Do I buy or do I not buy? Well, it's not quite that simple, right? Because if I buy, there's some possibility, a 60% chance, and let's put a 6 here, that I make the train, and a 40% chance that I'm late. So now I've got to decide, okay, what do I do? Because now it's a little bit more complicated. Well, to finish this off, to use this tree so I can make a good decision, all I've got to do is put the values of each choice. So if I don't buy the ticket, then I'm going to be out $400 because I've got to buy the expensive ticket. If I do buy the ticket and I make my train, that's great, because what happens is I'm only out $200. But if I buy my ticket and I'm late, then I'm out $600. And so now I've got all the information that I need. I've got all my payoffs at the end of each branch. I've got the probabilities of each branch, right, 60% and 40%. And so I just have to figure out what's the best choice for me. So let's make this all nice and clean. So here's all my data, and I've just got to decide what's the better choice. It's clear if I don't buy the ticket, I'm out $400. So what if I buy it? Well, there's a 60% chance that I'm out $200, plus a 40% chance that I'm out $600. Well, if I add this up, that's 120, 60 times 200, plus 240, and 120 plus 240 is 360. So what I get is if I buy the ticket, right, I'm out $360, and if I don't buy the ticket, I'm out $400. So it's a fairly easy choice, right? Buy for $360, right, or don't buy for $400. And here, since I want to have the lower cost, what I'm going to do is buy. So that was a fairly simple example. Let's do one that's more complicated. Suppose you're thinking about applying for a scholarship, and it's worth $5,000. That seems like a pretty good deal. And they limit the scholarship to 200 applicants, and you go into the office and you realize you can be one of the first 200. Now, for the scholarship, you have to write a 2-page essay. And after you write a 2-page essay explaining why you deserve the scholarship, they're going to pick 10 finalists. And those finalists are going to have to write 10-page essays. So now I got this choice. You could basically get $5,000. That's a lot of money. But you've got to write these 2 essays, a 2-pager, and then if you make it as a finalist, a 10-pager. And there's some probability of making it as a finalist and some probability of winning. So you look at this and you think, how do I make this choice? Well, again, what do we need to know? We need to know the probability of events happening, so the probability of making it to be a finalist and the probability of winning, and that's pretty straightforward. And we need to know the payoff. So we know the payoff from the scholarship, but we need to know the cost of these essays. So to use a decision tree, the first step you're going to make is to figure out the cost. So let's suppose you figure, well, what's the cost to me of writing a 2-page essay? And you figure, well, maybe 20 bucks. Maybe it's worth $20 worth of my time to write a 2-page essay. Now, what about the 10-page essay? Well, the 10-page essay, you could say, well, maybe that's only $40. Maybe it's only $40. I've already written the 2-pagers, so I've outlined my ideas, and I'd be sort of excited about having be a finalist, and it's not that hard to expand on my ideas, so let's just assume $40. So now I've got everything I need. I've got my benefits and my cost and all my probabilities, so I just have to draw the tree, right? Well, that's right. First step is draw the tree, but then once I draw the tree, I've got to write down all those payoffs and probabilities. So I've got to make sure I've got everything in there right. And then once I've got everything right, I can solve it backwards just like I did before. I can figure out the value at each branch, right? And then figure out what choices I should make. So let's draw the tree. The question is, do I write the essay or not? Well, if I don't write the essay, I get nothing. And if I write the essay, well, now it's a little more complicated because what can happen? Well, there's going to be some random node here where I could be selected or not. And then if I'm selected, I can decide whether I want to write essay 2 or not, but I probably will. And then there's going to be some random thing whether I win, yay, that'll be great, or whether I lose, and that won't be so great. But what I want to do is not have these smiling happy faces and sad faces. I actually want to put in the numbers. So let's do it. This isn't too hard. Again, if I don't, that's 0. What's the probability of selected? Well, 200 applicants, 10 make it to be finalists, so we can assume this is 5%, right, 0.05, and there's a 95% chance I lose. Now, essay 2, I can either do it or don't do it, and then if I win, here's another chance node right here. What are the odds of me winning? The odds of me winning here are 10%, 1 out of 10, and there's a 90% chance I lose. So those are all my probabilities. Now I got to figure out my payoffs. Well, if I don't write the essay, my payoff was 0. If I write the first essay and lose, I'm out $20, so that's minus 20. If I'm selected but then don't write the second essay, which is sort of a crazy thing to do, I'm also out $20. If I do write the second essay and lose, I'm out $60 because I wrote 2 essays, one for 20, one for 40. But if I win, right, then I get $49.40. I get the $5,000 minus the $60 for the cost me of writing the essay. So let's clean this up a little bit. So here's the total analysis, right? Here's the beautiful game tree with all my probabilities. What I've got to do is I've got to figure out what's my payoff, right? What's the payoff from doing these things? So we just work our way backwards. So let's start right here. If I win, there's a 10% chance I win. That's 49.40. So I can take 0.1 times 49.40 plus 0.9 times minus 60. Well, what is that? 0.4 times 49.40 is 494. Right? And 0.9 times minus 60 is minus 54. So what I get is 440. So what I can do is I can put a 440 right here. I can basically wipe out all this stuff over here and put a 440 there. Now, so if I look at this question then of do I write essay 2, it seems really obvious, right? If I write the essay, my expected winnings are 440. If I don't write the essay, my expected winnings are minus 20. So again, let's clean this up. So if I write the essay, 440, if I don't write it, it's minus 20. It seems pretty clear, right, that I should write the essay. So now it just comes down to this. If I write essay 1, there's some chance I'm going to get selected. If I'm selected, my expected winning is 440. If I'm not selected, I'm going to end up losing 20. So what's this worth? Well, 440, I'm going to get that 5% of the time. But 95% of the time, right, I'm going to lose 20. So I've got to add these two things up. Well, 440 times 5% is 22. And minus 20 times 95 is minus 19. So if I add those two things up, I get 3. So what that means is I could replace this whole branch, again working backwards, with a 3. So now if I look at my decision, should I write the essay or not? If I don't write the essay, I get nothing. And if I write the essay, my expected value is $3. So what should I do? Well, I should probably write the essay because it's got a positive expected value. Now the interesting thing here is if there had been 300 applicants or 400 applicants, right, maybe I don't want to write the essay. So what the tree does, what this decision tree analysis does, is it helps us figure out, was it really a good thing to do? So that's how you use decision trees to make decisions. Let's do something a little bit trickier with them. Let's do something where we try and infer what other people think about probabilities. So suppose you have a friend and they say, look, I know about this investment, and it sounds a little risky to you, and they say, it's going to pay $50,000, you know, I'm almost sure, and you've only got to put $2,000 in. She says, look, I'm in. I'm investing my $2,000. This is a great deal. You should invest. So you've got to decide, you know, do you want to invest? Well, the first thing you want to figure out is, what does she think the likelihood of this thing really is? What we can do is we can draw a tree and say, you know, I can invest or I cannot invest, and there's some probability that this will succeed, and there's some probability that it's going to fail. And if it succeeds, she's going to make $50,000, and so would I, and if it fails, I'll lose $2,000. So let's try and figure out what our friend is thinking. So what our friend is thinking is that 50p, right, minus 2 times 1 minus p is bigger than 0. So she's figuring the end of this branch right here, before chance takes its move, is higher than 0. So if I work this through, it says 50p minus 2 plus 2p is bigger than 0. So if I bring the p's all to this side, right, I get 52p has got to be bigger than 2. So what she's assuming is p is bigger than 2 over 52, or about, you know, right around 4%. So now I can look at this investment thing. Do I really think there's a 4% chance it's going to pay off? Clearly my friend does, because she's in. And I can decide whether or not to make the decision or not. But I can also infer, and this is the key point, I can infer from her decision that she thinks that, even though this is risky, that there's way more than a 4% chance that it's going to happen, because otherwise she wouldn't put her money in it. Okay, so decision trees, even if we don't know the probabilities, if we look at someone else's actions, we can infer what they think the probabilities are. Now, one last thing that's sort of fun. We can use these trees to infer payoffs, and sometimes we can use them even to infer payoffs about ourselves, like how we think about things. So here's the scenario. It's kind of a fun one. You've got a standby ticket, right? You've got some standby ticket to go visit your parents. You call the airlines in the morning of the flight, and it's like, there's a 1/3 chance that you're going to make the flight. 2/3 chance you're probably not going to make it. So you've got to decide, do you go to the airport, right, or do you just stay on campus and not go home for the weekend? Well, suppose you decide not to go. You decide to stay at the airport. You can use a decision tree to find out exactly how much you really wanted to see your parents. What do I mean by that? Well, let's see. So here's the decision. You stay on campus, and let's just make that a baseline payoff of 0. You can go to the airport, and there's a 1/3 chance you're going to make the flight. And let's call this V, the value of seeing your parents. Now, there's a 2/3 chance, right? And we'll put in a little cost here, minus C, for, you know, a couple hours of your time to take the taxi to the airport and back, or take the train to the airport and back. Alternatively, you cannot make the flight, and there the cost is just going to be the straight minus C. Well, since you chose to stay at home, what that means is this. That means 1/3 times the value of seeing your parents minus the cost of going to the airport, right, plus 2/3 times minus C, the cost of going to the airport, has got to be less than 0. What that means is 1/3 V, and if I add up the C's, minus C is less than 0. So if I work all the way through this, what this means is that V is less than 3C. So it means your value of going to see your parents is less than 3 times the cost of going to the airport. What that's telling you is, well, maybe I didn't want to see my parents very much. Now, if you did go to the airport and try and fly standby, that's saying the opposite. That's saying that V is bigger than 3C, and it's saying that you really did want to see your parents, which is a great thing. So I'm sure your parents would love to see you. Okay, so we've done decision trees here. Lots of fun. What we've shown is when we've got these decisions to make where there's lots of probabilities and contingencies, these trees are really helpful. They're really useful in helping us make at least reasoned decisions. Now, again, you don't have to adhere to what the model tells you to do, but the model is, again, a crutch, an aid, a guide to help you making better decisions. We also saw you can use these trees to infer what other people are thinking about probabilities, right? So when our friend made that investment, we could infer that she thought there was at least a 4% chance that thing was going to pay off. And then the last thing you can do is, after the fact, you can think, I made this choice. What is this choice saying about how I think about the world, or how I think about my parents, depending on what you thought the probabilities were? Okay, thanks a lot.